Okay, this is, I think, kind of where I'm going to end this part of the project right here. A couple things. I went to just a couple of these 10-year shelf life AAAs on this particular driver unit, and then I added the upper bushing that Simple Fix suggested to keep the rotor from wobbling and hitting the electromagnet and stopping, and that was a problem he was having and I was having. It was the middle of the night. All of a sudden you wake up in the morning and the thing stopped, and he figured out, and I did too, that it was the wobbling of that rotor that hit the coil and stopped it. So by adding a little bushing at the top, he's using a brass bushing, I just used a plastic bead on the end of a toothpick just to stabilize the top of that needle enough so it doesn't hit the rotor. And I went ahead and put the needle on the ground. That's a strip of brass with a little magnet underneath it to hold it there, and then there's a magnet at the top suspended up there. And this is that Dad Have circuit, basically modified with backup CPU and some of the stuff I've did and other people. It's a complementary transistor circuit with just a 10 meg resistor on the one transistor. There's no other components, just two transistors, the LED, one 10 meg resistor, and then that coil, which is Theodore Poly's design. That's a 4,000 ohm 42 gauge coil, and this is what I'm just going to let sit here on the shelf. It's in this plastic bottle, and that'll keep the dust off it. Then I have a little drying crystal packet inside the bottle to keep the moisture content very, very low inside there. And I'll just let this sit here, and I'll let this sit here until it doesn't run anymore, and we'll see what happens. I've got other things going on here too. This is just a solar operated one that uses that really nifty little solar waver. And then that's the easiest way to go if you want to just do a quick and dirty. Get a dollar store waver and put a 1.5 volt battery on it with a 30K resistor in series with it, and then just tie it right into the solar panel, and that'll run for a long time. And then this one here, I'm just going to let this sit here until the battery bursts. And the battery's up at over 1.63 volts right now, and it's being overcharged. And this is running non-stop, and the battery is being shoved with more energy than the motor's consuming. And years ago I had a dream that I had developed a self-runner, and I was testing it, and I woke up in the morning, and I'd forgotten to turn it off the night before, and I woke up in the morning, the whole thing was covered in frost, and the battery had burst from being overcharged by the motor running. And this is kind of something I want to just see. I'll watch this every day and see when this actually blows up from being overcharged. It may not. It may just keep on going and stabilize at an over voltage, but that dream is one of the things that kept me going all these years, with that dream of waking up in the morning and the self-runner had absorbed energy from the environment and gotten cold, and it was all covered in frost, and the battery had burst from being overcharged by the self-runner. And it was just one of these fanciful dreams that kept me going on this project. But this will probably simulate part of that dream, because as this solar panel keeps overcharging that battery, I think eventually the battery will burst, and I'll be watching to see when that happens. It won't explode, it'll just split probably, but we'll see what happens. But this gets faster every day. This was the 1.5 volt motor that was going pretty slow initially, and now it's sped way up. And here again, it reminds me of that dream that I had. Anyway, this is kind of where I'm at with this on the shelf simulated perpetual motion machine. If you get a chance, go over to Simple Fix's channel and take a look at how he's got a really pretty one. It's in a globe, a plastic globe, and it's all lit up and everything. But this was a fun project. Thanks for watching.